Hey everybody, in today's video we're going to take Pink Box Hero here, create new state machine that we can use to control him, and get you set up for the next video where we're going to start building the run and idle states. All right, now as we get started looking at our player here and how we're going to improve it, I want to just quickly review what I did with the level. So I issued a homework assignment for you guys to go ahead and flesh out this little scene and build a little level. And you can see I even came in here and I created this little rotated sprite down here so that I have a slope to walk on. And I'm going to go ahead and just run this real quick and see if it works, and it should work. I hope some of you guys tried something like that out. And by default, these character body 2Ds that Godot has, they handle slopes like this pretty well. And we might run into some minor issues with it later on, but as you can see, I can move up and down the slope just fine. But there we go. I've got a level. I've got a little block here that I could jump on. I made that block 2 pieces tall, so I just kind of scaled it by 2 so that it's 64 by 64 pixels. And then that way I kind of have a good reference for maybe what a larger block looks like. What we're going to be talking about in this video is, of course, the player state machine. And what we built in our previous video was this really simple rudimentary player with a simple script. And we've just got a few things happening here in our physics process, and we're doing some input detection just to kind of test things out. A really good comment in my last video mentioned how he hears that we shouldn't really be multiplying the velocity by delta before we use move and slide, because move and slide will already account for the delta, and he's 100% correct. But we are not actually multiplying the velocity by the delta. We're just multiplying this gravity amount to see how much gravity to apply. And so there could be, some confusion there. But this is not a bad practice, but it would be a bad practice if we were to just, multiply like that and try and use delta, because again, move and slide is smart and does that for us. But what we're going to do is we're going to look at this player and we're going to talk about building a state machine. And if you aren't unfamiliar with what a state machine is, it's simply a way to break up the code, control or manipulate the player based on states. And a state could be something like idle, running, jumping. Those are the states that we're going to be building. Okay, but it could be any kind of state that you want. And probably what you're going to have in a game like this is for each ability that you have, you're going to have a state that's associated with it or that performs that ability. Okay, so like our dash. Double jump, you could say is its own state, and maybe it is, or it could be built into our jump state. And then we'll have things like the morph roll and all these other things that we're going to build, right? Now, I just want to look at an example of a player script. Now, this is not a very complicated script, but this is one way that a player script might start to look as you start building out abilities. If you were to continue down the road we've been going, where we're building everything in the physics process, then you'd have checks to see if we're not on the floor and we're not climbing, which we're not going to do climbing, but this is just an example I pulled from somewhere. And then when you have movement, you have a couple different checks here. And then if it's climbing, you do this, otherwise you do this. And if it's dashing, then we would have to write some code here to handle that dash state. And you can see how this is starting to get a little bit complicated. And this isn't terribly complicated. And for a simple game, if it were just this and you were done and it worked perfectly, then that would be fine. I wouldn't care too much. But you can see we're just mixing more and more and more all into this physics process function. And it's getting kind of complicated. And we've added booleans for these, like, is it jumping? Is it dashing? What's the dash timer? Can he dash? Is it attacking? Now imagine if we're adding and doubling the number of abilities, how crazy that could get. And a lot of these checks that are happening that are nested if statements are going to get more complicated and ultimately more bug prone. And so a state machine will help us, because instead of having these checks in here, what we'll do is we'll just run our processes like normal, like our physics process, and then we'll offload the handling of what should happen with that physics to whatever state we're currently in. Now, there's a couple ways to do this. One way that people build state machines is they build it in the player script, just like this kind of. This is almost like an embedded state machine, but not quite, because they're relying on multiple variables instead of one to tell it what state they're in. The other way, and the approach that we're going to look at, is building a finite state machine that uses nodes for each state, okay? And I want to just kind of talk about an example of a state machine for those of you who maybe don't really understand it just yet. Okay, so in this example, if the player had 3 states, idle, run, and jump, then it might look something like this. When there's no player input happening in the game, then you're in the idle state. But you can see as soon as we press left or right, then we're going to enter the run state. And upon releasing the button, you might go back to idle. The same would be true if you press the jump state. And then of course, once the player is back on the floor, we would trigger an idle state. And so essentially what a state does is it performs the certain action upon a certain condition, right? In this case, button presses or releases, or in the case of the jump, a button press, and then the jump state will end when it lands on the floor. And so each state will be able to handle and manage like the velocity of the player. It will be able to do things like set or play animations, as well as any other complicated logic that we need to perform. And in addition to that, each state will determine when it's ready to move on to a different state. And now that may happen based on player input, like we've demonstrated here, or upon interacting with the world, like in the case of the jump where he lands on the floor. And so that, in essence, is what a state machine is. And it's often called a finite state machine, which is more or less what we're building because you can only be in one state at a time, right? You can only be in run, idle, or jump, and not all three. This might sound like it's a little bit limiting, and it is going to actually introduce extra code. There are a few downsides to state machines. Like, for example, when we're done with what we're building today, it's going to feel like it's overkill. It's a lot of extra code. Okay, that's one potential downside to a state machine. It won't be in the long run because it'll be a lot easier to work with once we add all of our abilities. But for just walking and running, it is quite a bit of code. State machines can also make it a little bit slower to move through and read the code. That does come with clarity, of course, too. So there's a pro there as well. We will also be duplicating some code, like we'll be handling inputs in each of our states. And while we may not have complete redundancy of code, there will be some redundant bits of code. And that could be viewed as a downside, but again, this is also a plus side because while you may be listening for the same button press in multiple states, you may actually have a slightly different reaction, and maybe you won't. And then lastly, state machines are pretty rigid, and so you might run into situations where they won't scale super well or support some sort of advanced feature that you want to build. I think the finite nature of this state machine is one of those. So like if you wanted to have a jump and attack, and in a regular attack, then that might be two states. In the case of this game, we're going to build it so that there's only one attack state, and I think you'll be happy with how that works. But again, you might run into situations where you're like, nope, I need my attack to be different. And so now you're just building a lot of extra states to accomplish the feature set that you want. But all those things aside, this is a really powerful design pattern, and it's going to be really useful. Not only is it going to make your job easier as you start to learn to code, but if, a month down the road, you realized you really need to add a new ability, it's pretty easy to be able to create a new state and drop it into your state machine. And you have to make minimal, if any, changes to your other states. And so it makes it really versatile in that fashion. Okay, so to start creating our state machine, we're going to actually start by defining the PlayerState class, okay? And so let's go ahead and just come down in here into our project. I'm going to expand player. And instead of putting the PlayerState stuff in scripts, I'm going to stick it here underneath states. Right click, create a new script, and I'll call this, I'm going to start it with 2 zeros so that it's always at the top of the list, underscore player underscore state. Now that we've created that, let's open it up, and I'm going to give this a class name of player state, just like this, and it can extend node, that's just fine, okay? And so what we're going to be using this player state class for is really it's a definition of what a state needs to perform. And so this particular script here, this player state script, is going to be extremely bare bones. We're going to write functions that are going to do basically nothing. But this is just so that we can, again, set up a structure for how all states need to function. And then this will allow us to build our state machine code within our player script to be able to expect certain functions within our player states. And while we're at it, I'm going to go ahead and I'm going to add an icon to this. So here in our player, I'm going to go ahead and just open this states folder in my file manager. And this is the point where you need to make sure that you can go to my itch.io page, which will be linked in the description, and download the chapter 1 asset pack. You're going to find 2 files in there. You're going to find an icon, and you're going to find the sprite sheet for our player. We're not going to be using that sprite sheet for the player just yet, but we will use the icon today. So go ahead and download that, open it up or extract it, and then we're going to grab that SVG file and drop it here into our states folder. Okay, you can see I've got mine here. There's the state SVG. I'm going to go ahead and drag this and just copy it into my folder. And then when I come back to the project, it'll import it. And then up top of the script on line 1, I'm going to just type @icon. And then here in the icon, I'm going to leave a space and I'm just going to click and drag this little file and drop it right there. And that's going to put the resource path for that SVG. And you're going to see that once we start adding these states, and we're going to have to relaunch our project as well, probably for this to happen, but they're each going to have icon here in the scene tree. And it's going to look like this little state icon here, except obviously it's going to be small enough to fit in that spot. When we look at our states, each state will need to have a reference to our player scene so that it can manipulate it, right? And because we're building a player with a specific class name of player, we want to reference that as well. So what we'll do here is we're going to define a variable and we'll call it player, and it's going to be of type player. So what I mean is we'll call it player, and then we're going to add this colon, and then I'm going to type the class name, which is a capital P player. Just like that. This is known as strict typing. So this is a variable that has to be of class player. So we're going to be able to store a reference to some node that has this script attached to it, which, right, is our player here. Like if we look at our player here in the scene tree, this guy, he's got this script attached, and you can see there it's the player.gd script. So by that logic, this player node is a player class script. So we'll be able to store a reference to it in this variable that we'll call player, and then all of our states will be able to manipulate it as needed. The other thing that we're going to store in here, and we will only use this occasionally, is just going to be a variable for our next state, which is a variable of type player state. So it's going to be something that is a player state or that extends that class. Now the next thing I'm going to do, and this might not be best practice if you're trying to make a generic state machine, but we're making one that's specific to our player and will only be used for our player. And so what we're going to do is we're going to make here, I'm going to make a code region. So let's see, hashtag region, and then the 3 slashes are just a stylistic thing that doesn't mean anything important. But I'm going to just call this state references, just like that. And then I'm going to go down and I'm going to end the region. And now you can see we've got a little collapsible piece of code. And so that's all this region does, is it allows you to kind of just give this little label. It's nice, it stands out in purple, and it's collapsible. So you can define variables in here, and if you have a lot of them, then you can just collapse it because you might not need to look at them most of the time. And we're not going to populate this just yet. I'm just going to leave a comment in here. What this is going to be is this is going to contain a reference to all of our other states. And this is going to make our code just a little bit easier to write. Now, some people might differ with me on this one, and so feel free to drop in the comments if you think there's a different or better way to do it. And the way I'm doing it in this video is different than I've done in the past. I've created 2 different state machine videos at this point here on YouTube, one for the Action RPG series and one for my platformer series. And I've implemented them both in slightly different fashions, but following the same general concepts. Okay, so we're going to utilize this here extensively. Every time we add a state, we're going to drop a reference to it here. Now it's time for us to just define all the functions that are part of our player state class, and meaning any class that extends it needs to have these functions and needs to provide their own functionality for them. And so what we're going to do is we're going to start with a function that we'll call init, okay? And I'm just going to say pass. And what the init function will do, and I'll put a comment here, what happens when the state is initialized? If we need to initialize certain variables or get a reference to something in the game world, then this init function is the place to call that, okay? We'll be hooking up to that later in our player code, but the next function that we need is an enter function. Now, what should the enter function do? This function is the function that we will call anytime we enter this state. And so things that might happen when you enter a state are playing an animation, maybe setting or resetting a variable, or starting a timer, or something like that. Each state will also have a function for when we exit the state. Now, much like entering a state, exit might need to do something like reset a variable, clear a timer, disconnect from a signal, or something along those lines. Now, the exit function will probably be used less extensively than the enter, because virtually all states will do something in their enter function. Not all of them will need to do something when they exit. Next, we will have a function to handle all of our inputs. But this is different, because when we handle an input, you'll notice on all of these, I'm writing this little arrow syntax with the word void. What this signifies is that this function does not return a value. What is returning a value, you might ask? Well, returning a value is simply saying, when I call this function, I want it to give me something back. So like if you were to have a function that said add 2 numbers and you provide it 2 numbers, you would expect the sum to come back, right? And so if that were the case, right, if we expected a sum to come back from this handle input, then we could say that we're expecting an integer back. something like that. When we say void, like these ones do, that means don't worry, we're not expecting anything back from this function. And so you're going to use this return void quite often. In the case of handling input, however, we do want to see if we should change state based on the inputs pressed. And so what we will expect from this handle input function is that we return a player state, just like that. And because we're expecting a return value, we can't end with pass, because you can see that not all code paths return a value. You see that warning there? When we add the syntax and put a type, then this means the code is expecting us to return something. Now there's two things that we could do at this point. We could either return null, and null just means nothing. Like, I know you're expecting something, but sorry, I don't have anything for you. Or we could return the next state. And the next state up here, because we've not initialized it, is the same as saying this, right? So we're going to still be returning null. But keep in mind that we're just writing a template for all the functions that we need to have, not all of the guts that they're going to do per state, right? So we'll be filling this out with like input handling and things like that. We're not quite done with this function yet, but it should be obvious at this point that this is a function that handles what happens when an input is pressed, or released, I guess, for that matter. But because we want to handle an input, what we're going to do in here is we're going to pass in what that input is. And so we're going to provide an argument for this function. So you just go in between these parentheses and type in event. I'm using underscore. And then this event is going to be of type input event. This is important because we're going to be leveraging the unhandled input function built into Godot, which gives us this type of event. And then we're going to just pass it into this function. Now, there's just two more things that we need to handle. We've already set up these placeholders for entering, exiting, and handling input within this state, but we also need to know what happens during our process and our physics process during this state. And so we'll make a function for each of those. And normally, if we were using the process function, like we did in our last video, we would do it like this, underscore process, and then we provide the delta, which I'm going to give an underscore because we may not need it. But what we're doing is something different. We're not going to be using the built-in process. We're going to be using this underscore process from within our player, and then we're going to call the state's process function. So I'm just going to remove the underscore so that it just reads process. And just like our handle input, we're going to make this function return a player state. Okay, and of course we've got that warning. Let's go ahead and return a value so that we can get rid of that. And there we go. Now we have a way for controlling what happens during the process loop of this state. Now I'm going to copy all of this and create our final little function down here. And this is going to be our physics process. Just like that. It's going to take the same delta input. It's going to return a player state. And so we can leave this return next state just like that. And this is what happens each physics process tick in this state. And there we go. Now we have a template for everything that a state should do. Okay, now just in case you need to, here's the top part of that script. You can see all of the functions except for a couple, and I'll scroll down now so you can see those. Process and physics process, okay? So that's everything that you need in this script file. Now we're going to move on to our player script because we need to modify this significantly. I'm going to remove everything in the physics process for now. And what we need to do is set up this script so that we can use it as a state machine, meaning this script is going to run the states, it's going to handle the switching of states and so on. So we'll do that code here. So I'm going to come up here and I'm going to make a code region for some variables and some properties that we're going to use. Okay, so we're going to have state machine variables, and what the state machine needs to keep track of are all of our states, just so that we can manipulate them if needed. The current state we're in, and then we'll keep track of just maybe the previous state, okay? So I'm going to say variable of states is, this is going to be an array, and if you don't know what an array is, it's like a list that you keep, and we could just say array just like that, and that's fine, but I want this to be an array of a specific type, and so I'm going to put these square brackets, and then inside the square brackets, I'm going to type the class name that I want this array to contain, and you probably guessed it, that's going to be player state, just like that. When we initialize our player and our state machine, we will use this array to get a collection of all of our states and run that init function, which hopefully will make some sense. But then eventually we're going to clear that out, and we're going to just use this essentially as a history of our current and previous states. And then you can adjust how many states you want to keep in memory. Next, we're going to have our current state. Now this is of course of type player state. Now this is a unique function because this function we're going to use as a getter, which means that this function doesn't store data. Instead, it's kind of like a placeholder for us to be able to request data. And so I'm going to put a colon after player state. So we've got 2 colons in there, current state, colon, player state, colon. And then on the next line, I'm going to type this, get, and then we're going to return. Remember that from our player state here, right? We return when we're expecting a value from a function. Okay, so that's kind of what this is saying here. We're going to return a value. And in this case, we're going to go to our states array, okay, which is this guy we've defined up here. And then there's a function. Since this is an array, we can call dot front. Let's go ahead and just look at that real quick. Returns the first element of the array, or in other words, the first item in the list, right? If the array is empty, fails and returns null, which is fine. We're not going to worry about that. But this will give us the first state in the array, which we will identify as our current state. Next, we're going to make one more variable called previous state, which is also a player state. And this will also be a getter function. So we're going to add that second colon here and then type get. And this time we're going to return the second item in the array. Now, how do we get the second item? If we put some brackets after an array variable like this, then we can identify which item we want by the index. The index you can think of as the number of the item on the list. But there's a catch because arrays don't start counting at 1. They start counting at 0. So what that means is if we want the second item, we return item at index 1. Okay, that might sound confusing, and it kind of can be, but you'll get used to it as you get used to programming. Now, we're going to have a second region for some additional variables, and you don't have to put these in regions. I just like to because it organizes the code, and not something I've done in my previous tutorials, but this will really help clean things up. Okay, so we've got this region for standard variables. This will make it so that it's nice and easy to collapse. So see, I've got these state machine variables. If I want to condense my code, blink, I can just collapse it, and you can see based off of the little 3 dots that there's more to read, right? So for our standard variables, there's a couple things that we're going to need now, and then we might add to this later. But for now, we want 2 things, and that's a directionality for our player, like which way is he facing and or walking, and then one for the gravity. Okay, so I'm going to start with the direction. And this direction is going to be used to kind of determine not simply where we're walking, but maybe which direction we're pushing on the inputs. And so this is going to be of type vector2. And a vector2 is a special variable that has 2 components, an x and a y component. So you could think of it something that you could chart on a graph. And we need to set a vector2 to something. So by default, I'm going to set it to vector2 dot 0. Another way to create a vector2 or write it would be to put the numbers in parentheses like this. So 0 on the x and 0 on the y, just like that. That vector2 dot 0 is exactly the same as typing what I just typed here. It's just 0 on both. And then the other one that I mentioned was our gravity. And this is going to be a float, which is a floating point number, or a number that supports decimals is kind of the simplest layman's term description for that. And we're going to set this to 980. That was the value that we had plugged in that felt okay while we were playing around with the platforming before. So these standard variables are variables that we're going to be able to reference throughout our code. And so anytime we need to reference gravity, we can now type the word gravity instead of typing the number, which doesn't sound like it's that big of a deal. But let's say you had, used this number in 5 spots throughout your code. Now, instead of having to find all those and replace them, you just could change the value on this gravity variable. And then everywhere where you've referenced gravity, it will update. The first thing that we're actually going to do in our script after we've defined these variables is build our ready function. Now, the ready function in Godot is the function that runs as soon as a node is added to the scene tree or to the game and is setting itself up, more or less. And this is how you write that, _ready, and it returns void, meaning what? It does not return a value, right? And what we need to do in here is we want to initialize our states. And we could do that all within the ready function, but just to be safe, I'm going to write a new function that we can call that will do that for us. So I'm just going to make a comment here to remind myself that this is where we need to initialize our states. And then I'm going to come beneath my physics process here. I'm going to go ahead and minimize this standard variables region. And let's make this new function. And it'll be called initialize states. It's worth pointing out, if you're new, you can't have a space in a function name like that. And I like to use the Godot suggested syntax, so that's this snake case where you use an underscore for spaces. This function doesn't return anything, and it doesn't require any arguments to be passed into it. And so that's all we have to write to create that function. And this function essentially is going to set up our state machine. The first thing we'll do is we will take this states array that we've defined up here, and we'll make sure that we create a new array. We can just assign it to an empty array like this. And then what we need to do is we need to gather all of our states. Then once we've gathered them all, we need to initialize them. And then the last step will be to set our first state. Now we're at a point here though where we can't really move forward because we don't have any states. So let's go ahead and create some placeholders that we can use for this. So I'm going to go ahead under my player, add a child node, and it can just be just a node like this. And I'm going to give this node the name of states. And then what we're going to do is we're going to add nodes underneath this. So again, I'm just going to add a regular old node. Now, each of these nodes, I'm going to give a name of the state. So we're going to make two states to start. It'll be idle and then run. So give them those names. Now what we can do here is, I guess we should assign a script to these because these are going to each have their own unique script. But for now, I'm going to just select them. And then I guess we could grab this PlayerState script and drag it on. Maybe drag it into this script box here. That only assigned it to idle. Let me assign this to run as well. There, now both of these have a PlayerState script attached, so it'll work with this code. So in order to gather them, what I'm going to do is I'm going to say for C, which means for each item that we're going to call C, in, and we have to tell it where to get them. And so I'm going to grab this states here. I'm just going to drag and drop it, and it's going to put this little green string where it says $states. It's a reference to that node. .get children. Okay, so what this does is it's going to get all of the nodes that are children of this node. And it's going to go through them one by one, and they'll each be called C when we look at that particular node, right? So we'll look at the first one and we'll say, okay, C, what are you? And then we'll go to the next one. Okay, C, they're all going to have the name of C. We're going to do a check. We're going to say if C is a player state. Okay, which it is because we've attached this script, right? And if it is a player state, then we want to add it to this states array right here, our list. We're going to add it to our list of states. So we'll say states.append, and then we'll just pass in that C. There we go. Okay, so if we run this, then we should find two states, right? So I'm going to go ahead and just come down here, and I'm going to print our list of states like that, and we'll see what happens. Nothing happens. Wonderful. I guess it's probably important that we call this function. We haven't done that. We made a comment that we need to call it, but we didn't actually call it. So let me replace that and hit F5 again. Okay, so let's go back. Okay, this little print piece of code will output it here. And you can see that it found two nodes, idle and run. Perfect. Okay, so we know that we're getting these states. So far, so good. I'm going to remove this. We don't need that anymore. There's one other thing we want to do. Each state that we grab, not only do we want to add it to our list, but if you recall, each state has a reference to our player. And it's not set yet. And so we can set it. So we're going to say c.player equals self. Self refers to this class and this node, which is of type player. So because this is looking for something of type player, we can just assign it ourself, and there we're good to go. The next step here is to initialize all of the states. So when we initialize our states, this is what we're going to do. We're just going to say for state in states. You'll notice this is another for loop, just like this. I'm using state instead of C, and we're looking just at our states array. So it's just going to go through all of the states that we've collected here, right? Which in our example were idle and run. And then we're just going to call each state .init. Okay, that way if there's any init code in any of our states, it'll run it. Now, I'm going to go ahead and save this, and I want to show you something. I mean, this isn't really going to do anything just yet. Let's go ahead and go to our player state, and in the init function, let's just print init, and then we will type comma outside of the quotes here and type name. That's going to be the name of this node. So if I run it, I should get two print lines. init idle and init run. You can see that they each ran their own init function, right? Does that make sense what we're doing there? So even though we've got this code once in this file, because we have two nodes using that script and we're calling that function on each of them, it's going to print that out for both. Now there is something, if we were to move these states out and run again, then I think we're going to get a bug. We didn't. Okay, we could potentially, I think. So just in case, I'm going to go ahead and stop that. I'm just going to build a failsafe in here. Sometimes I build these in and they almost aren't needed, but I think they prevent some random bug every now and then. I'm just going to say this. If states.size equals 0, the size function is just going to get the size of that list. If it's 0, that means we don't have any states, so I'm just going to return. We're not going to do any of the other code. Return will end the function, even if we're not returning a value. This ends the function, in this case, prematurely. Because even if this bit of code doesn't fail, this next bit would if we didn't have any children states. But down here, setting our first state, we're not quite ready for that because we don't have the functions that we need to call. We're at a point with this initialize states function where we're going to move on to a new function. And this function is going to be used here in initialize states, but also generally anytime we want to change a state. And so that's the function we're going to create, change state. So down here at the bottom, I'm just going to go down a couple lines and type in func change state. Now this function, we're going to need to provide it the state that we want to change to. So here in the parentheses, we'll create that argument. And I'm going to call it new state. And this is of course of type PlayerState. Okay. So what does this function need to do? It doesn't need to do a whole lot. It needs to make sure that this state that we've passed in is a valid state. Maybe we can check to make sure it's not the state that we're already in. You know, if like we keep passing idle in, then we can ignore it if we're already idling. And then what we'll do is it's going to go through and it's going to just take the state that we're in currently. Anytime we're going to change, we're going to take the existing current state and call its exit function so that it can do what it needs to exit. And then we will set this as the new state and then call this new state enter function so it can do everything it needs to do to enter. And that's pretty much it in a nutshell. So let's do the first part. I mentioned we want to check to make sure it's a valid state. So we'll say if new state equals null, which means we don't pass something in. That's going to sound funny. You're going to think like, why would we ever call it without passing something in? But remember how we end these with return next state and our next state hasn't been defined? So actually, we're going to be calling that change state with that blank state quite a bit. And so this is going to happen all the time. We're just going to return. We're not going to do anything if that happens. So it's like, oh, we had a change state signal, but there's no new state. So just ignore it. And then let's do another check. So if, right? So if that first one passes, we have a new state, then we'll do another check. And we'll just check to see if the new state is the same as the current state. 2 equal signs is how we check to see if it's the same object or the same value. Now we're also going to return in this condition, okay? We could write these in one line, but this is a little bit easier to read. So I'm just going to keep it that way. Now the next thing that I mentioned was take our current state and call its exit function, right? I am going to put an if check on here because at least when we first initialize this, there might not be a state to exit. So if current state is all we need to write there, meaning is it a valid state? Is it a valid object? Then we'll call current state dot exit. Just like that. Next, we want to take this new state and make it the current state. And the way this is going to work is we're going to just take the new state and make it the first item in this states array. Because remember, that's how we get our current state. So we'll just come down here. We're going to say states dot push front. Okay. And then we'll say new state. What this is going to do is it's going to take this new state, it's going to make it the first item in that list and push all the other items down. So it won't replace the first one, it'll push the first one down to the second spot and so on. And then of course, now that we have a new current state, we can call current state.enter. Just like that. And so that's going to call the enter function on that state. And then one last thing we want to do is, and this is actually kind of important because if we keep adding states to this list, that list is going to grow and grow and grow. And you imagine that's going to change thousands and thousands of times as we play. We don't want to keep track of thousands. So I'm going to do this. We're going to call our states array dot resize. Okay, and this function, we have to provide it a value. I'm going to say 3. which is just going to say, hey, look, I only want to keep 3 variables in here, 3 items in this list. It's going to keep the first 3 and it's going to remove the rest. Okay. So that's going to keep it manageable. That way we have our current and a previous, and then like the one before the previous state, right? Because as that pushes down, we're always going to have 3 and they're going to be in order of the current and most recent. Now, if for some reason in your game you felt like you needed more, you could increase this, but I would keep it reasonable. So there we go. We've got a change state function. I'm going to go ahead and save this. And now we can finish our initialize states function, right? So setting our first state here, we're going to call change state. And then we're going to pass in current state, which is going to grab the first item that we found in our node tree, which in this case is idle, right? Because that's going to be the first one we get. And that's good. And that should be enough to get it going. I'm going to remove these little commented out sections here, or not these comments out, but these little comments. Okay, so we're going to gather our states, make sure that we have one, initialize them, and then change to our first state, just like that. Okay, so what this is going to look like is we should see that we will enter the idle state. Now, because we don't actually have any code in these, I am going to do a couple things here. Let's go into our state class, and I'm going to copy this little print statement, and we'll put one on enter, and we'll change this to enter, colon, and then we'll keep the name, so it'll tell us which state just entered, and we'll do the same on exit. This way we can kind of see if our states are working. Okay, and then let's go ahead and just add it here to handle input, colon, and then we'll put the state name. Okay, we aren't going to do this for process or physics process because that's just going to like add print statements to the console at a rate of 60 per second or more, right? So let's go back to the player script. This should give us an enter here because we should be entering the idle state first. So let's go ahead and run our game and see if that happens. We got our inits. I didn't see the enter. And actually, I think there's a small little bug in here. I'm going to go ahead and go like this, and I'm going to just say current state.enter. And let's see if this fixes it. There we go. And we just need to call that because when we start out, this isn't fully initialized. And so we need to call that enter manually. It's not going to make it far enough through this to actually do that on the first time around. Okay. Now we've managed to get our initialize states and change state functions set up, and I hope that you're following along because I know this is like throwing you into the deep end if you're new to Godot and to programming, but bear with me because we're almost done with setting up our state machine. So now that we've got these working, what we need to do is let's go back, and I'm going to go ahead and collapse these functions here. Let's go back to our process and our physics process. Because if you recall, we had code in here before, we removed it, and we're going to add some back, but most of the code that happens in these, we want to come from our states, okay? And so let's just go ahead and we'll start with a process. Here's what we're going to type. We're going to type change state. Okay, so we're going to call the change state function, and you can see that it expects at least one argument, and the argument that it expects is the new state. So how are we going to get the new state? So here's what we're going to do. We're going to go ahead and inside of this, we're going to get our current state dot process. And then this is expecting a delta value, which we have right here. So I'm just going to take that underscore delta, pass it into this change state, save it. To be able to see if this is working, let's go ahead and go back into our PlayerState script here. And just for a moment, I am going to copy and print. I'm going to print this p colon name, and let's put the delta in here. Okay, so we should be seeing a whole bunch of stuff coming out for the state. Let's go ahead and run our project now. Yeah, you can see it going like crazy. And you can see that we're getting a pretty consistent number, but it is slightly different. Like some of them appear to be different every now and then. But that's basically, it's been 0.0069 seconds between ticks. But you can see that we're just running the idle state over and over and over, the process function. So had we had code in there, then it would be doing that code. So let's just go ahead and stop for a second. And actually, let me go back to running that. I want to show you something cool. We don't have to stop. I'm going to go back to Godot. And here in the process, I'm going to comment out this print statement, and I'm going to hit save. And I'm going to clear this down here. You're going to see we're no longer printing out. Okay. Game is still running. here's what I'm going to do. I want to set the velocity on the player, and I have a reference to the player, right? We've provided that variable, and we've set it up in our player here when we, where's initialized states? In here, we're setting the player. Okay, so each state should have a reference to him. So if I come in here and just like set the velocity dot x equal to 10 or something, then he's going to start moving, maybe. Oh, we don't have move and slide over here. So let's go back to player state. Instead of player.velocity, let's say player.position. And instead of saying equals 10, I'm going to say plus equals, and let's just make this small, plus equals 1. Now when I save this and go back, he's moving. Okay. He went through the wall because we're moving his position. We're not using move and glide. But there you go. You can see that this is happening because it actually moved him. So I'm going to go ahead and delete this. And we're going to stop running the game because our player's like, who knows where at this point. Okay, but we can see that that process was working. And then let's go back to our player here, and we're going to go to our physics process, and we're going to do kind of the same thing. I'm going to copy this, and I'm going to come down here and I'm going to paste it. And instead of running the current state's process here from physics process, we're going to run the physics process, right? Physics underscore process, pass in the delta. Same thing will be happening. So if we wanted to come in here, we could go to our physics process and we could print physics. Yeah. Now, if we run it, we should see that spam in the console. Okay. You can see that it's happening, right? Okay. So we know our physics process is being called. And then lastly, we'll come up here to our handle input. We've already kind of provided a print statement here. We just need to go back to our player script, and we need to do that here. So we don't actually have a function yet to handle input. So we're going to add one new function, func underscore unhandled input. Now you can see that this unhandled input provides an input event. And if you recall in our player state, that's what this is expecting. Okay. So it's going to be the same thing. We're going to type change state, right? But this time, instead of calling current state process or physics process, we'll call the current state dot handle input. And we need to pass in our event just like that. So if I run the game, let's see what happens here. I'm getting a bunch of input idle. Oh, hold on. Oh, because I guess technically we have something happening. I'm not sure what. So what we're going to do to properly test this is we need to do a little bit of a check in here. So I'm going to write if underscore event, and I just went over to the player state script if you didn't catch that. So if our underscore event dot is, we're going to say action pressed, and then we'll just pick jump maybe. Okay. So we're going to say if the jump was pressed, then I'm going to actually put in here jump. Okay. So let's see if this works. So technically I should only see something if I push the jump key. There we go. You can see I'm pressing the jump key, and each time it's outputting that to the console. Okay. So now we've effectively hooked up our regular functions, but instead of handling them within the player, we're going to handle them within our player state here. So, looking at the player, we've got unhandled input is a built-in function. We're calling our current state's handle input. And what will happen is within our state, if we ever determine that they need to change, like, let's go ahead and do this. If it's the jump action, I'm going to go ahead and say return, and then we're going to have a way to get the state we want to return. And I'm just going to go ahead and drag this in here. Let's see if this works. Okay, you can see that we entered the run state. So what happened there is because I returned a state, now this script, it says, okay, yeah, just check. Oh, hey, we got the run state. When we go down to change state, it's going to say, oh, this is a new state. Let's exit the old one. So you got exit idle. And then let's enter the new one, enter run. Okay. Now, what we've done by putting this code in here is kind of goofy. I'm going to go ahead and delete this, and you need to as well, because we want this player state script to be back to its basic, clean, no code version, just like this, right? Not no code, but the functions are empty. Go ahead and save that change, and then come back to our player. And we're going to do two things. We're going to get this set up, and then I'm going to give you guys a homework assignment. Now, the two things that we're going to do is first, we're going to set up just a little bit more code so that we get our gravity back on our player, okay, and do some direction input detection. And then secondly, we're going to set up empty versions of the idle and the run states and assign those, okay? And your homework assignment is going to be to see if you can kind of make those work, to play around just a little bit, all right? So what I'm going to do is I'm going to come in here. Let's go to our process function. I'm on the player script. In the player script, I want to get my directionality, the button presses I'm doing. We're going to do this in a new function so that we can kind of keep it clean. So I'm going to make a function that we're going to call update direction. Okay, that function doesn't exist, so of course we get a warning. So I'll copy that name, come down here to the bottom of my script, and let's create a new function called update direction. Okay, so update direction is just going to do a couple things. We're going to get a reference to our previous direction, which is going to be, of course, it's a vector2. Now, I strong type all my variables. You can do it without that. You can just set it equal to something. There is a notable performance improvement in Godot, in GD script, if you strong type your variables, meaning you provide the type every time you declare a variable, because it means there's less overhead for the engine to figure out what type of variable it is, and so on, okay? So I'm going to go ahead and just set this equal to our direction, which, as you recall, we're just setting to 0, 0 right now when we start. I mean, we set that up at the very beginning, right? We've got our standard variables. So let's get this, let's assign it as a variable we'll call previous direction, and this is going to allow us to do some kind of detection. Now we're going to get a new direction. Direction is going to equal, and we're going to go input, okay? And this input global class has some really nice stuff in here. There's one function called getVector. Okay, and what this does, you can see the little hint here, but I'm going to go ahead and open it. It takes a negative x, negative y, and a positive y. These are string names. These are input names. And what it does is it gets a vector based off of those. So what we do is we pass in left, right, up and down button action names, and it's going to calculate the direction that we're pressing. So if we're pressing up, it's going to be like 0, -1, right? If we're pressing down, it'll be 0, 1, and so on. And likewise, we can even get diagonal directions with this. So let's go back here, and we just need to provide the action names in here. So you can see they started to pop up. So we start with our negative, which is left, negative x, then our positive x, which is right, because we've already bound those in our input binding, right? So then we need, what is it? Negative y, which is up, and positive y, which is down. There we go. So now we're going to get a new direction based off of our inputs. And later on, we're going to do more code here. But for now, this is sufficient just to get our direction. And we'll use this previous direction later on down below. In fact, we're getting this stupid warning. I'm going to go ahead and comment that out for now. I probably did that prematurely because I'm looking at my other code, but this is the key thing that we need in today's tutorial, right? It's just to get that direction. I'm going to save this. Whoa, my debugger's going nuts. It's because my game's running and something isn't working. Okay, and actually I can see that I've got a typo with down. I don't have space down, it's just the word down. So save that. So now I should be able to run it. That's funny, I didn't realize I still had the game running in the background. It's not doing anything, but we're getting our direction, okay? And this still part of this first thing we're going to do, I guess. So maybe there's three things we're going to do. We're going to come to our physics process, and we still want to do our gravity simulation in here. We could do that in a per state, but it makes sense to just do it on the player here. And we'll just start with a basic implementation of it. And so we're going to go velocity.y. And previously we were assigning it, but I'm going to say plus equals. So we're going to change y by whatever's on the right side of this statement. We're going to take our gravity. We're going to multiply it by underscore delta, because we are wanting to see how much gravity has been affecting this over the last change in time since the last frame. And there we go. So that's just going to give us some gravity. So if I run this, we should see, oh, the player's not falling. Oh, because we're missing another critical component. We never added move and slide. I should have never moved it, I guess. Move and slide. We need our move and slide in our physics process. And in fact, I want it before our change state. That way our state has a chance to do its code before it exits if needed. So let's go ahead and run this again. Okay, there we go. We're falling. We can't move left or right. We still don't have that control, but we do have our gravity back, and we're doing our move and slide, and then we're going to do our state specific code. And then the next thing that we're going to do is set up our basic idle and run state scripts. Okay, in order to create these scripts, I'm going to come here to my states. So looking at the player scene, we've assigned a script to each of these. I'm going to go ahead and clear that real quick because we assigned this player state script and we don't want that. What we want to do is we want to come in here to our states folder and let's create a new script. Okay, and this first script, we'll just call it idle. Just like that. And then if I open idle, it needs to do a couple things. It needs to be a player state script, right? So just like this one says extends node, we want our idle script to extend player state. So let's go ahead and change that. Okay, so now this is a player state script, but we also need to provide it with all of these functions. It's not really required to have an init function if we don't need it, right? But I'm going to just go ahead and copy all of these and come into idle, and I'm going to paste it. And I want to do one last thing. I want to come in here and I want to give this a class name of, we'll call it player state idle. Okay, so it's going to look just like this. Okay, so we know that this is a specific version of the player state that is used for idling. Okay, what you're going to do on your homework assignment is you're going to take this script and make it do something, right? I'm kind of giving you a clue here. So now that we've built this idle script, we can drag and drop it onto our idle state. And then we're going to do the same for the run state. So I'm going to go ahead and just duplicate this idle script. I'm going to call it run. We might get an error for a second here because this is called player state idle. And change that to player state run. Okay, there we go. Okay, and then we can attach run over here. Hey, nice. You can see that one got the little icon. I don't know why the idle one didn't pick that up, but the run did. Okay, so we've got our run and our idle script. I think I hadn't saved player state idle just yet. And if you want to get these fixed, you can restart the project. You can go project, reload current project. Make sure you save all your changes before you do that, of course. Okay, so we've got these two states. If we run our project, it should still kind of work. We're going to fall, but nothing happens. So the challenge for you is going to be to look at this player scene. You've got two states now. We've set them up. You can see the run has the run script attached to it. The idle has the idle script attached to it. Okay, they're both states. They should work in your state machine at this point. They're just not doing anything. And what you need to do is you need to come into idle and see if you can find a way to get the idle state to transition to the run state. Okay, you're probably going to want to use handle input. And we've done some examples of how to do handle input here, so you might be able to figure that out. And likewise, if you can get that working, then come to your run state and see if you can figure out how to get this to go back to your idle state and see if you can build that out. So that's your homework assignment. In the next video, we're going to cover how we're actually going to build that going through the rest of my tutorial here. So we'll build out the idle and the run states, and we'll address a few additional things, clean up the run state, make it work a little bit better, and add some debugging as well to our state machine. And that will set us up to move on to our platforming state, so our jump and our fall. And as always, I hope you're enjoying this content. Please drop any comments below if you have them, if you have any questions. Subscribe to my channel if you want to see what's coming next. And as always, we'll see you next time.